C, and I will draw the crank circle through point C. Okay, now I have the reference circle on which the position of the crank will lie. So now again, with radius equal to 1500 mm, that is my length of BD. So I need to mark D. 360 degrees are there on the circle with center C. Where is my other crank? It will be in relation with the crank AB. So I need to mark the position of D with respect to B, which is given to me. BD is equal to 1500 mm. So with radius equal to, I have already drawn the crank circle. So I'll move on with radius equal to 1500 mm and center equal to B. I'll cut an arc on my circle and name it D. This is my driven circle on which I have cut the arc, and this is my driven crank. Now I have the static link, I have my driving crank, I have my driven crank. So what is my next step? Connecting rod. The only thing that is missing. So this is my figure. So I have the 4-bar chain mechanism or 4-bar link mechanism. Let's check once again. We have 4 links, 1 A, B, C and D. Okay, I have my driven crank, I have my driving crank, I have my driven crank, I have my static link, and I have my connecting rod. Okay, so I'm sure that the figure is ready. Now I have to plot the locus. Now for plotting the locus, first of all I'll mark point Q. How will I do that? For point Q, I will extend BD from B, beyond B, 300 mm. How? Take a look at this. I have just extended this, put this point as Q. For this particular point, I have to find the locus. What is the other point that I need to find the locus of? From D, I'll put this particular point P, for which I have to find the locus. So I now have the point P's and Q through which I need to pass my locus. So again, I will now follow the same procedure that I did back then. Now you'll ask, how will I follow the same procedure? Now in that, what happened? I divided the circle into 12 parts. Here also I'll do the same. But there is one single difference. As there was simple difference between simple slider crank mechanism and offset slider crank mechanism, there is a little bit difference between the offset or simple slider crank mechanism and this particular 4-bar link mechanism. What will I do? Now I will divide the circle into 12 parts. The driven circle, the driving circle. This is the circle which I will divide into 12 parts. So I'll have different positions of the driving crank. Now what do I need to do? I need to plot the positions of the driven crank according to the positions of my driving crank. Matlab, I have the position of AB. So I got the position of CD. Now if I have position say AB1, so I'll have the position of say CD1. This is what I need to do. How will I do it? First I'll divide this into 12 parts. Then I will take my B1, radius equal to BD, cut an arc on this particular circle wherever it is suitable. So I'll get the position of D1 according to B1. So let's see. 12 parts again. Let's divide. Let's do the same old story again. B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, and finally I have B11. So these particular things, or say these particular lines and these particular notations from B1 till B11 gives me 11 different positions of the crank, and B will be the 12th position, which I already have. So now again what I want to do, I want to, according to that, say I'll take A B1. Now I want to find the distance, or sorry, the position of the driven crank according to my driving crank's position AB1. So again, the same thing that we did, the radius will be taken equal to connecting rod in all cases. All cases, the link which is moving, which is connecting both the driven and the driving, will always be taken. So I will take radius equal to BD first. Now I'll decide the center. The center is going to be B1, and I'm going to cut an arc on the center with C like this. D1. Now you notice that my B1 is moving clockwise and my D1 is moving anti-clockwise. So I am sure that I am fulfilling the question, the condition in the question, that both the cranks are rotating in opposite directions. We have to make sure that this happens so that the question is correct. Now what I'll do, I will join B1 D1. So this is my connecting rod position with respect to B1 and D1. Now what I need to mark my position of Q and P. So I'll extend it. This is my Q1, and I will cut an arc at P1. So this is my P1. How did I do that? The same way as I marked Q. From B1 I'll extend the rod D1 B1 beyond B1 300 mm and mark point Q1. Then how will I mark P1? With center as D1 and radius equal to PD. That is PD is 300 mm again. So I'll cut an arc on B1 D1 from D1 to P1. So I'll get the position of B1. For same position I'll repeat the same procedure for B2, B3, B4, B5, B6, B7, B8, B9, B10, B11. That's it. So let's see. I marked position D2 as you can see it here, and then I'll join, see this line that has been joined, and then again I'll extend this to mark Q2, and here I'm marking P2. Same, this distance is 300 and this distance again is 300. I like to mention a thing that please don't go on the measurements. This has been made roughly, but it will give you a accurate idea. It will give you an accurate idea how the mechanism and the locuses look like. It will not give you the accurate measurements, for which the PowerPoint presentation have, say, a drawback. Okay, now for B3, again same, I draw the D3, then I'll connect B3 D3, mark Q3, mark P3. That will go on. For P4, for I have B4 D4, I have Q4, and I have P4. Similarly for B5, B6, B7, B8, B9, B10, B11. Final. So what do I have? I have the different positions of the crank, driving crank. I have the different positions of the driven crank. I have the different positions of connecting rod according to that. I have the different positions of Q with respect to each and every position. I have the positions of P with respect to each and every positions. Now what will I do? The same old procedure that I did. I say the same old procedure because the same thing is being repeated and repeated. So if you draw one curve, if you practice one curve perfectly, you will be able to do the other curves, but it does not mean that you should not practice the other curves. You should practice as many curves as possible, because in each and every particular curve you will encounter a little bit difference, and you know that little difference can make a lot of impact on the say any procedure. So now what will I do? Now I want the locus. So what will I do? I'll connect all the points of Q first. From then I'll go to Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q10 and Q11. So here we go. We got a circle. It does not look like an ellipse, it does not look like a circle, but it is a smooth curve. That's what you have to make sure. It should not have edges. So this is my required locus of point Q. Let's move to the other end and draw the locus of P. From P, P1, P2, P3, P4, like a rhyme, you should connect all the points from P to P11, and you have the locus that is required of point P. So what did you learn? You learned the same thing that we discussed before, but with different conditions. Okay. The next example. I hope you are clear with the first three examples that you have discussed. If there is any problem, please do ask your teachers and clear it out. Don't leave any doubt uncleared because if you have even a single doubt that is unclear, then that could result in the final figure being deformed and the correct answer being not achieved. Okay, now first of all I would like you to see the mechanism which we are going to, this is another example that we are going to study. So first of all I would like to show you the animation. What is this? Have you all seen a pendulum? Yeah, we have all seen a pendulum. It is there and it keeps on oscillating at particular intervals and has perfect extreme times. Now what is this? This is a particular point. This is the pendulum. Now what speciality of this pendulum is that first of all its limits are defined. Its limit is from extreme left to extreme right, and a particular degree is given. That is given in the question. When we will draw the figure for it, we will discuss. Now the speciality of this pendulum is that this particular guy has something different. This has a rotating disc at the end of its rod. As you can see, this is the initial position of the disc, then it rotates anti-clockwise and keeps on rotating anti-clockwise, goes on and on until it reaches the extreme end and it completes 180 degrees. This particular is completing one oscillation where this is completing 180 degrees, and it comes back to its original position and it has completed the whole circle. Now we'll come back to it in a sec. First we'll read the question. Now you have seen the mechanism, so it will be easy for you to visualize what kind of question this is. So after the question we'll again go back to the mechanism and see what is there. A link PQ is 100 mm long. Now just imagine the link that was oscillating from extreme ends, that is 100 mm long. Can you imagine? Yes, please do imagine. Carries a circular disc. The disc which was there, kuch khas hai. That disc is rotating and it has 30 mm diameter, having center Q. I have not marked it in the animation figure. We'll draw it and then we'll mark it. The link PQ oscillates about the hinge P, that above point that was given, from left to right, from left hand to the right hand. It keeps on oscillating. Now vice versa to maximum amplitude of 45 degrees. So on the left we have a vertical. On the left hand side it will go 45 degrees, and then again on this side it will go 45 degrees. Again it will go 45 degrees this side, come here, then again 45 degrees this side. So what basically happens is that if it starts from here and I go 45 degrees, this is my 45 degrees, it comes back to 0, then again it has 45 degrees. So I am covering an angle of 90 degrees in whole. So this is very important to know ki what angle the extreme positions are making with each other, which is given in the question by this particular statement, that it has a maximum amplitude of 45 degrees on both sides, on left as well as on the right. Okay, at the same time the disc rotates uniformly one revolution in clockwise direction. The disc is rotating in clockwise direction, or we can say the anti-clockwise direction, whatever we want to assume. Okay, the next is draw the in this question it is given clockwise, so it's not that whatever we want to assume. I just said if it is going clockwise we'll draw it clockwise, if it is given anti-clockwise we'll draw it anti-clockwise. Draw the path of point on circumference of the disc. There is a point on the circumference of the disc, so we need to plot the locus of that particular point. Come back to the animation. The question is getting more clear. This rod, the length of this rod is given. This is hinged at here P. This is PQ. This disc is rotating clockwise from left to right. So what the question says is, once it from this point, we'll just let it come to the particular position and we will see. This is the beginning position. So from this the disc is rotating clockwise and it is oscillating towards the right. Now from here till here the disc rotates through 180 degrees and this particular travels 90 degrees. So this is the particular point and this is the particular point for which this is the particular point for which we have to trace the locus. Now it won't be a simple circle because this particular thing is moving, and this is just showing the circle on which the crank is moving about this particular point. Okay, now let's get down to drawing the figure. Okay, again the same old story. First draw the reference lines. Now there will be two reference lines, one will be horizontal and one will be vertical. This is the horizontal line. Why I have drawn this? I have drawn two quadrants because I need oscillations in both the quadrants. Now I'll put my point P, where at the intersection of both the lines, just here, as you can see here, it appeared somewhere here. Yeah, here it is. Okay, now what I want to do? Now I want to first mark the extreme positions of my pendulum. Here we go. First of all, I'll need to draw my reference circle. That is 100 mm is the length of my PQ, so I'll draw a circle. This is 100 mm radius circle which is drawn for its center P using my compass, if anybody is not aware of it. Now what I want PQ. PQ is 45 degrees from this vertical. How do I judge it is 45 degrees? Because I want to it starts from left and it goes to right. So my first position or my extreme position here will be PQ, and which will be 45 degrees from this particular line. So what I'll do, I'll mark an arc here from this 45 degrees and I'll mark this as Q and I will join PQ. This is my initial position and this is 45 degrees. Okay, so this is my extreme left hand position, and now I'll have PQ dash. This is my extreme right hand position. Again this is 45 degrees. So as you can see, the whole area on which my oscillation is going to take place is 90 degrees from Q to Q dash. The next thing that we are going to study is, these are the limits P and Q. The Q and Q dash are the extreme positions beyond which the oscillation will not be taken place. Now here we have been given the radius. The radius is, now as we see, the radius is there. So taking the radius equal to 50, sorry, there's a mistake in this. It is 150 mm, I'm sorry, 15 mm, and we will draw a circle with center as Q. It is 15 mm, the radius is 15 mm because that is the link that is rotating, or the crank wheel that is rotating. So it is 15 mm and center as Q. I will draw the disc. Now understood? This is the first position of my disc. Now what I'll do is, I'll extend PQ beyond Q up till the end of the circle to get my first point. This is my first point and I'll mark it as 1. I'll mark it as 0 because this is my first point, initial point, that is starting point. So I'll mark it as 0. So now this particular point that I marked 0, I have traced the locus of this particular point. So how will I do it? First of all, it is very necessary to know that what will be what are the divisions that we are going to make. Then again we'll divide the particular, for one revolution we'll go on, okay, we will divide the circle into 12 parts, each of 30 degrees. How 30 degrees? Again the same old story, that's my favorite word, that is 360 degrees divided by 12 is 30 degrees. So I will mark 1 2 3 4 5 6 7 8 9 10 and 11. So my circle is divided into 12 parts. Now one thing is there in the question, that it is given that when the link PQ completes one half of the oscillation, that this particular, this particular link from here it moves up till here. So what happens is, this disc completes half rotation. So if I am starting with 0, this particular position when I reach, it will be 180 degrees have been completed. So when this link oscillates 90 degrees, this particular disc rotates 180 degrees. So what calculations I have to do? See, half oscillation of PQ is equal to half rotation of the disc. So what happens? Hence we can divide the 90 degrees into 6 different parts, because what I know ki halfway, so I have 6 points. I have divided the circle into 12 parts, so 6 parts will be covered. So my whole division has to be 90 degrees is my travel time, travel distance, and 6 parts. So